Hello, my name is Scott Gorham. Good afternoon. I am with Sprinklermatic Fire Protection and Fire Alarm. Today we're going to go through the basic operation of an electric fire pump. We're going to run through the maintenance, and we're going to run through the startup and shutdown procedures of a fire pump. What we have here today is our electric fire pump. We're going to go through all the different valves that work this fire pump. We've got a maintenance pump, which is going to be considered as our Jockey pump. We're going to have our Jockey pump controller, and we're going to have our fire pump controller. We're going to run through all these different tests right. Start off our fire pump. We've got our little signage here just so we can actually look at it. This is going to be our supply control valve. This is going to be our main valve for the fire pump, our supply valve coming from the underground. If we had to do any other type of work on this, this would be our valve that would shut the water off to the fire pump. So we do have our supply control valve. This is going to be our valve, our main valve coming in from the underground supply, feeding our electric fire pump. We have two bypass valves, control valves. Both of them are going to stay in the open position. In case for some reason that our fire pump didn't come on or was not working or anything like that, city water would still come through this, bypassing the electric fire pump. On our Jockey pump, coming right off the underground, we also have our Jockey pump supply valve. It's an OS&Y valve. Also, just like the electric fire pump, we have a discharge valve, also for our Jockey pump. To work on any bit of the fire pump or the Jockey pump, we would close our supply and our discharge to both of our pumps to do any work or any service on the fire pump. All right, we have two sets of pressure gauges that we're going to look throughout this whole whole presentation. We have our suction valve, which is going to have us down to -30 if we started sucking the city water dry, up to 300 psi. Then also we have our discharge valve. When the fire pump's on, naturally whatever our discharge pressure, roughly about 190 psi, is going to go up in here. These two gauges is when we are running our pump for our weekly pump runs. These are the two numbers that we are going to write down on our sheet of paper showing what our supply is and what our discharge is. Again, this is going to be our suction pressure gauge, and this will be our discharge pressure gauge. Both of these, when the pump is not running, will be at the same pressure. Of course, when the pump is running, our supply is going to be the same, and our discharge will be up to whatever the pump churn is, roughly about 190 psi. Over here, we have our one-way directional check valve. Whatever pressure comes off the fire pump, the pressure, you have city pressure on the supply side, and on the discharge side, you have whatever the fire pump discharge is. We have our control valve. This is for our test header. This valve will only be used once a year, and it's in the normally closed position. We use this valve once a year whenever we do the fire pump performance flow test. Used once a year, and it's normally closed. Over here to my far left, we have an OS&Y valve, which is going to be our discharge control valve. By shutting this valve off, we kill all water supply to the building from the fire pump. All of our control valves have a tamper switch on them. Each time one of these valves are shut with a turn of 5 turns, you would get a tamper, which is going to go back to your fire alarm panel saying that the valve is closed. Every time we do a weekly startup, we're going to make sure that all the valves are in the open position, except for our test header valve. All these valves that we have inside the pump room are all indicating. This is an OS&Y, which is an outside stem and yoke. Plus we have our tamper switch, which has a groove inside the stem. As soon as that valve is closed, the arm comes out of the groove and sends a trouble to the panel saying that the valve is closed or partially closed. Same with the OS&Y that we have for our Jockey pump. It's got a groove in the stem. When the arm comes out of the groove, we would get a trouble to the alarm panel. We get over to our other type of valve, which is going to be our butterfly valve. Its indicator is out here on the outside. When the valve is open, it's parallel with the piping. When it's closed, it's perpendicular. Also, these valves also have a tamper inside of them also, but they work off the inside. As soon as you start to close this thing after 5 turns, you have a trouble going back to the fire alarm panel saying the bypass valve number 2 is closed. As far as our maintenance goes on the electric fire pump, it's very easy. We really don't have anything, no fluids naturally that we have to check. What we do is we have our outboard and we have our inboard bearing housings. Both at the top have a grease fitting, and at the bottom they have a little Allen wrench or a set screw that comes out. On an annual basis, we're going to take grease, maintenance or whoever does it, your fire sprinkler contractor. The only maintenance skid is this grease fit. You're going to grease here, you're going to pull the Allen wrench screw out of the bottom, you're going to pump new grease from the top until the old stuff comes out, screw back in the bottom, give it 1 or 2 pumps. It's about the only maintenance that you have that's going to go under the electric fire pump on your annual basis. Everything else is going to be pretty much preventative maintenance. We have our drip cups right here on the inboard and on the outboard packing. These packings are supposed to drip. You should have 1 drip per second. It's natural for somebody to come in here and take the swing bolts and tighten these packings down to where they get tight. And then during the operation of the pump, you start to have smoke, a little steam coming out from the packings. You want to keep this thing dripping, like I said, 1 second or 1 drip per second. The daily maintenance thing that we usually have is that these tubes down here on the bottom, the drain tubes that go out to the drain, after time builds all up, these drains will start to get clogged all up. Got to make sure that both the inboard and the outboard, the 1/2-inch hole that goes to the drain, stays clean. If for some reason they start to fill up with water, it's going to come up. The water's going to sit in the drip cups, and it's going to get into the bearing housings. As you start to get that water into the bearing housing, you're going to eat the grease up, and then you're going to start corrosion, start rust, and your bearing and your packing is going to get all torn up. So we got to make sure that we keep the drip cups clean, the 1/2-inch hole on the inside and the outside, and the annual grease on the front, the inboard and the inboard and the outboard that we change out only on the annual basis. We don't pump any grease into it on the monthly basis, strictly just annual. On both of our jockey pump and our fire pump, both of them are set up with a pressure relief valve. Both of these are set at 175 to 185 psi. If for any reason the fire pump or the jockey pump should build up any more pressure, it will not go into the system. Both of these are tied back into the drain system, which will drain outside the building. Both the fire pump and the jockey pump have this. The jockey pump one will hardly ever be used. When your fire pump runs, when it's at its churn pressure where you're not flowing any water, you will see water coming out of the discharge pressure relief valve and dumping outside. That's going to keep this water from inside here from getting it hot. During your 10-minute run cycle, as you're running the pump, you're always going to want to keep your hands up here and feel it. Make sure we're not getting hot inside the head. We're going to make sure that your relief valve is always dumping water. Every time we start this up, first thing we're going to want to do is walk outside and make sure that our relief valve is dumping water out. This is going to be our jockey pump controller. This is going to be our disconnecting means to the controller, our main power break right here. The jockey pump controller is strictly a jockey for the jockey pump, and its only purpose is a maintenance pump. The only purpose of the jockey pump is to make sure that the fire pump doesn't turn on. This jockey pump, as we get down here to our pressure gauge, I've got 2 marks on the pressure gauge, and this is going to be our start, and this is going to be our stop. As you can see, when we get to 160 psi, the jockey pump's going to kick on, and it's going to stop at 180 psi. Our fire pump over here, when we get to it starts at 150 psi. This jockey pump should cycle weekly, daily, however it does, so that the main fire pump does not turn on. That's the only sole purpose of the jockey pump. It doesn't put out a fire. Only thing it does is to stop the fire pump from turning on. Like I said, by turning this little valve right here, you'll hear it cycle on and cycle off from 160 to 180 psi. And like I said, this particular controller strictly just works just our fire pump, our jockey pump controller over here. So this is our jockey pump controller, which is going to feed our one maintenance pump right here. Like I said, the only purpose of this is to strictly stop the big pump, the fire pump, main pump from coming on. It's going to cycle from 160 to 180 automatically just with loss of pressure. Our Jockey pump controller. We have our main switch, our main on and off switch. Off, on. Naturally, this is going to be in the on position, 24/7, 365. This is always going to be on. We have our selector switch. We have auto, which means the Jockey pump's going to work strictly by loss of pressure. Whenever it gets below 160, the Jockey pump's going to kick off, and it's going to turn itself off at 180, just with the pressure switch that's made inside here. We have the off position, and then we have the hand or the manual position, which as soon as you turn that over, the pump's going to run non-stop. It's only going to build up to a certain amount of pressure. It's not going to continue to pump up over 180, 85, 190 psi, but it will stay on the whole time. So we need to make sure that our full-time 24/7, 365, that our main switch is in the on position and the selector switch is in the auto. This is our fire pump controller right here. This is going to strictly work just the fire pump. Just as the Jockey pump works itself, fire pump has its own pressure switch in it also. It can also be run manually, or it can be started with loss of pressure. Also, like the Jockey pump, we have the brass half-inch line, which is our sensor line also. I've got a mark on here on our pressure gauge at 150 psi. As we open up that bottom valve, and the needle drops down to 150, we will have an automatic loss of pressure start of our fire pump. Anytime the fire pump starts with the loss of pressure, the fire pump has a 10-minute run time and it'll automatically shut off. So with the loss of pressure, fire pump starts. Once pressure is built back up to whatever building pressure is, 10 minutes later this fire pump will shut itself back off. If for some reason the manual button was pushed, start right here, you would have to manually shut this off by coming back here to the stop button. So low pressure start, it'll shut off after 10 minutes once pressure is built all up. If you do the manual start, you have to manually stop this. We have 3 switches that work our fire pump. The left side of this controller is going to be our normal power or our FPL. The right side is going to be our emergency or our transfer switch side. We've got 3 switches, our isolating switch, our circuit breaker disconnecting means, and our emergency isolating switch. I have in the 3 corners the procedure of turning the fire pump on and turning the fire pump off. If we were to shut this fire pump off, we're going to start with emergency first, where it says off number 1. We'd come over to the circuit breaker disconnecting means, we'd shut this one off. Then we'd come up to our 3rd one, the isolating switch, and shut this off. Now our fire pump is completely shut off. When we have a loss of power to this fire pump, we have a relay that shows that we have power of loss, which goes back to the fire alarm panel and gives us a trouble or a supervisory saying that the fire pump has lost power. You need to go check it all out, the switches. As we fire this thing back up, we're going to go do just counterclockwise. We're going to start with the isolating switch first. We're going to go to our circuit breaker disconnecting means it's going to be our 2nd one. Once I throw this switch all up, we're going to have the bell go off, which is going to tell us that our emergency isolating switch is in the off position. From the time we throw this 2nd one, we hit the alarm silence that'll stop our bell, and then we throw the 3rd switch up. Alarm silence, we have a red light saying that our isolating switch is still open. That's our 3rd and final switch. We have power normal, we have AC power, we have 2 green lights. The fire pump is ready to work in the manual or in the loss of position, automatic position. We're going to run through the basic operation of the Jockey pump. Like I said, our normal position is going to be our switch on and our selector switch in auto. This is a 480 volt panel along with the Jockey pump, so any access behind this door needs to be done by a certified electrician, 480 volts. We have our sensor line coming from our discharge side piping of our jockey pump. As this goes over on a daily, weekly basis, as we lose pressure in the sprinkler system, when we get down here to our black mark, which is going to be our start at 160 psi, the jockey pump's going to cycle on and it's going to shut off at 180 automatically. We're going to run through that procedure, and then, like I said, it would be just our jockey pump. So by opening up, this has two 3/32 orifice holes inside of it. So even though it's a 1/2-inch piece of pipe, the water that comes out here is going to come out spraying a little bit, but you're not going to get the full 1/2 inch. That way you can actually see what the needle actually start without the whole rush of the piping going in. So we're going to start this thing. We're going to barely bleed it open. Now the jockey pump is cycling. Once it got up here, if you opened it a little bit more, it would stay running. As we shut this thing all off, like I said, we're going to get back to 180 psi and it's going to shut off automatically. That's how the system's going to work. This is how we test it or inspect it from here in the fire pump room. Other way of testing it is if we were up in our building and we were on one of our system floor control valves, we could open up the inspector's test or the main drain. Once we had a loss of pressure coming from the building side, you'd see the pressure drop here. Naturally, when it got to 160, it would kick on and shut off at 180. Again, the jockey pump or the maintenance pump is strictly so the main fire pump doesn't turn on. Strictly a maintenance pump. It works automatically, stays in the auto position. As far as maintenance goes, there really is no maintenance on the jockey pump, just to make sure that it stays on and the selector switch is in auto. The bearings and everything is permanently greased. There is no lubrication or anything adjustments that it needs. Also, like I said, on the fire pump, the jockey pump has a relief valve also. If for some reason somebody had turned it in the man or the hand, the pressure would get up over a certain pressure, this valve would open all up and it would discharge water automatically and shut off when the pressure went back down. Both of these the jockey pump, both just like the fire pump, has a supply valve with the tamper. When closed, we'll send a trouble or supervisor to the alarm panel. You undo your fire pump. You've got a check valve also, which is a one-way directional valve. When the jockey pump's up, pressure above here will remain. You have city pressure down below it, and you have building supply pressure past this. We have our sensor line, which feeds our jockey pump, tells it when to turn on, turn off. And then we have our discharge control valve. Naturally, when it's closed also, we will have a trouble or a supervisory at the fire alarm panel saying jockey pump discharge valve is closed. That's pretty much the standard and basic operations of the jockey pump. This is our fire pump controller. We're going to run through the basic operation of the weekly test that should be performed by maintenance. For video purposing, we're going to strictly work on looking at the controller right here with the fire pump running. Then we'll turn around and repeat ourselves with the fire pump going over here. It's going to get a little noisy in here, so I'll try to speak up so we can understand me when the fire pump's running. As I said, the fire pump does work in an automatic and a manual position. We have our sensor line, which is our 1/2-inch brass feed that comes off our discharge side of our sprinkler system. Once that pressure gets below 150, which is 10 pounds lower than what the jockey pump should automatically start, once this gets to 150, our fire pump's going to start up. Again, if our fire pump starts up due to a loss of pressure, the fire pump, once it builds up its pressure, will shut off in 10 minutes automatically. If for some reason somebody comes out here and hits the start button, we have to manually stop it. The fire pump does not have an automatic stop feature. Once it's pushed start, you'd have to push the stop button. Once we get our 150 and we start on a low pressure, we're going to see our fire pump run, start all up. The pump's going to run. Our fire alarm panel is going to show that the fire pump is running. It's going to send a trouble or a supervisory to the alarm panel. You shouldn't get any alarms when this thing runs. All you're going to get is a supervisory. We're going to start the pump with the loss of pressure. We won't let it run to 10 minutes right now. Just show it how it starts all up. Show that the pump running does come back to the fire alarm panel. All right. Crack open the valve just the same way we did the Jockey pump. We've got our black mark here at 150 psi. Once we get to that 150 psi, our fire pump's going to kick on. As you can see, our timer is blinking right here. This is going to blink for 10 minutes, and after 10 minutes, fire pump's going to shut off. We have our pump status. We have our fire pump showing with the red light that it is running. We push the stop button here if we didn't want it to run the whole 10 minutes. Again, on our fire pump, if we needed to shut the power off, if we had to do some kind of service, this is also a 480 volt panel. Any work that should be done beyond these doors should be by a licensed electrician. If we needed to shut this power off for any kind of work on the fire pump, we have it on the sides. We're going to shut, for the off position, we're going to shut this one off first. We're going to shut this one off second, the disconnecting mean. And then third, we're going to shut off the isolating switch. Just opposite, counterclockwise, just to turn it back on. To turn it back on, you're going to throw the number 1 switch. You're going to throw the number 2 switch, the disconnecting mean. The alarm's going to go off saying that your emergency isolating switch is in the off position. We're going to hit the alarm silence button. Red light comes on saying that our isolating switch, emergency switch, is still in the open position. We're going to close that. Now the fire pump is ready for a manual or a low pressure start. We have a clean screen here, just the green lights. We're going to start the fire pump with a loss of pressure. We're going to run some water out one of the main drains. We're going to start it up with a loss, or it's going to start automatically off a loss of pressure. And what we're going to do is we're going to do the manual trip of the transfer switch. We have a test buddy right here. As our fire pump is running, we're dumping water. If for some reason FPL, fire department had killed the power to the building, the FPL, the normal power, this would automatically switch over to the emergency. We're going to show that doing it in a manual state by going with the test button. It's going to transfer over into the emergency transfer switch, and then we're going to transfer it back to normal. So we're going to open this valve over here. You can just keep looking right here at this control. I'm going to open this valve real fast. Now our fire pump has started on a low pressure start. You've got FPL normal power running it. We're going to push the test button, which is going to transfer from normal power, FPL power, over to the emergency generator. This usually takes anywhere from like 10 to 15 seconds to make the change. And then the fire pump should start right back up because we are on a low pressure. We are flowing water right now. You need to continue to hold the button until it completely makes the transfer. Generator is started up. Transfer switch is all up. You can see where the light is now. We are strictly under emergency power right now. We've got our digital readout, what our pressure is. We've got 170, 180 psi, but we're still flowing water outside the main drain. We're going to transfer this back to normal power. Excuse me, wrong button. We came back, now we're back to normal FPL power. We have our timer run light right now, which, like I said, is going to run for 10 minutes, and then it'll automatically shut the fire pump off. Little timer right there. What I